Today we will learn how to create the transfer function from a signal flow graph. The basic concept that we use to convert a signal flow graph into a transfer function is Masson gain formula. Now the Masson gain formula is basically says that transfer function or TF equals to summation of del k p k whole divided by del. Now here pk stands for forward path. Del stands for 1 minus summation of all loop plus summation of all two non-touching loop minus summation of all three non-touching loop and so on. Del k is the exact replica of del, but in case of del k, here we will consider only those loops which are not touching in the k forward path. Now, if we have to understand this formula, let's take an example. From this formula, we can understand that two main things are very important to solve a signal flow graph, which are forward path and loop. Now, if we consider a signal flow graph like this, let's assume here is the input x, here is the output y, and this is the way of signal transmission. This is one backward path, this is another backward path. Let's give some values to this path. Suppose this value of this path is g1, value of this path is g2, this one is g3, this one is minus h1, and this one is minus h2. Now see, from this, if we have to solve this whole graph and form the transfer function from this graph by using this formula, then first of all we have to proceed in such a way that we can segregate paths and loops differently. So first part, let's see how many forward paths are there in this graph. Now, to determine or to find out the forward path, we have to start from the input and we will end at the output, and in this whole journey we will never return once, even in once, from output to input. So as I said, we will start from here, we will end at here, and in between we will never return in this way. So if that is the way, then there is only one way in this graph, that is from node 1 to node 2 to node 3 to node 4. No other way, by no other way we can reach from here to here. So the only one forward path P1 is G1 into G2 into G3. Now let's see how many loops are there. A loop, the basic condition of being a loop is to start from a node and we have to end at the same node, and in the whole path no other node will repeat twice. So if we consider node 2, let's start from node 2. Node 2, travel here at node 3, then again return back to node 2. This formation is a loop. So loop L1 in this case is G1 cross minus H1, which is minus G1 H1. And there is another loop here. See, start from node 1 G1, then from node 2 G2, then from node 3 G3, then again return back to node 1 by minus H2. This one is a bigger loop. So there is another loop L2 equals to G1 cross G2 cross G3 cross minus H2, which is minus of G1, G2, G3, H2. Now there are no other loops in this graph. So we have segregated our two loops. Now see, if there are two loops or any such multiple number of loops in which there are no common node or no common branch, then those set of multiple number of loops can be termed as non-touching loop. Now let's examine here. This is my second loop and this is my first loop. But unfortunately, these node 2 and node 3 are common in both loops. Also, this G2 branch is common in both loops. So in this case, in this graph, there is no non-touching loop. So number of non-touching loop is non-touching loop equal to 0 in this case. Now let's form the transfer function. TF equals to summation del k pk divided by del. Now let's study what is del k. What I have told you that del k is exactly the formation of del, but considering all loops, those are not touching k forward path. Now here forward path is p1, so k equals to 1. So to form del 1, we have to consider those loops only which are not touching the p1 forward path, but this is the p1 forward path. First loop is touching that path, second loop is also touching that path. So in this case, del 1 should be 1 minus 0, because all these part, only those loops should be considered here which are not touching p1 path, but there are no such loops. So this total part becomes 0. So del 1 equals to 1. So now summation del k pk means p1 del 1 divided by del, which gives us G1, G2, G3 into 1 whole divided by del. Del means 1 minus summation of all loop. That means 1 minus L1 plus L2. Plus summation of all two non-touching loop. Now see here, non-touching loop equals to 0. That means in this graph there is no non-touching loop. So plus 0. So this gives us G1, G2, G3 divided by 1 minus minus G1, H1 minus G1, G2, G3, H2. Now simplify it. G1, G2, G3 divided by 1 plus G1, H1 plus G1, G2, G3, H2. Now this is the result or answer transfer function. Thank you.